Hello all, welcome to my YouTube channel. This is the part 2 of types of software testing. So today we'll be focusing on the functional testing. What are the types of functional testing? So till functional testing we have covered in the part 1, that is all about manual testing, white box testing, black box testing and gray box testing. So this we have covered already. So we will start today from the unit testing. So let's start. Unit testing is a crucial method for testing individual unit or component of software application, primarily conducted by developer to ensure this unit functions correctly. By isolating and testing specific parts of the code such as functions or method, unit tests help identify bug early to development process. This early detection prevents issue from becoming more complex and expensive to resolve. Advantage of unit testing: early bug detection. Identifying bug at an early stage help prevent them from escalating into more significant issues. Code stability. Unit testing ensure that changes made to the code do not introduce new bugs, maintaining the stability of the code base. Modular code. Unit testing promote writing modular code, making it easier to understand and maintain. And software quality. By improving the reliability and quality of the software, unit testing contribute to a better end product. For an example, in a program we are checking if the loop method or function is working fine or not. Misunderstood or incorrect arithmetic procedures. Incorrect initialization. Next is integration testing. Integration testing is a crucial process that evaluates how different units or components of a software application interact with each other. It aims to identify and resolve any issues that may arise when these units are combined. This testing phase typically occurs after unit testing and before functional testing, ensuring that the various units of the software function together as intended. There are several approaches to performing integration testing. Those are top down integration testing, bottom up integration testing, and big bag integration testing. And fourth is incremental integration testing. There are two types of integration testing. First is incremental testing, second is incremental testing. First we will see about incremental testing. It's a common approach used in software development during the integration testing phase, which occurs after unit testing. This method involves testing module one by one using stubs and driver to identify error and defect in the specific module. Advantage of incremental testing is each module has a specific significance, and testing them individually allow for focusing error detection. Defects are detected in a smaller modules, making it easier to correct them without the need of extensive edits. It is flexible and cost efficient, as testing can be tailored to meet specific requirements and scopes. Customers can provide feedback at each stage of development. Second is non-incremental testing. It's also known as Big Bang testing. It's an approach to integration testing where all the most of component or module of system are integrated simultaneously rather than incrementally. This means that instead of integration and testing individual modules or small groups of modules, the entire system is combined and tested as a whole. In non-incremental testing, the focus is on verifying and interaction and interfaces between different modules rather than individual modules themselves. This approach can be more challenging because if issue arises during testing, it can be difficult to pinpoint the exact source of the problem since multiple components are being tested together. Advantage of non-incremental testing is simplicity. It is a straightforward approach that does not require the incremental integration of module. Second is time saving. Testing the entire system at once can save time compared to incremental testing, where each module is tested individually and then integrated. Third is comprehensive testing. Since the entire system is tested together, it can uncover issues related to the interaction between different modules that may not be apparent in incremental testing. However, non-incremental testing also has some disadvantages such as complexity. Testing the entire system at once can be complex, especially for large system with many components. Second is difficulties in pinpointing issues. If problem occur during testing, it can be challenging to identify a specific module or component responsible for the issue. Third is risk of late defect detection. Since all components are integrated at once, defects may only be detected late in development cycle, making them more costly to fix. In top-down integration testing is an incremental integration testing approach where testing starts with high-level modules and moves down to lower level modules through the control flow of the architecture structure. High-level modules are tested first, followed by low-level modules. Stubs and driver are used in this approach. Advantage of top-down integration testing is no need to write drivers. Interfaces. Interface errors are identified early and fault localization is easier. Low level utilities are not extensive tested, focusing resources on high level tester. Second is bottom up integration testing. Bottom up integration testing is an approach where testing starts with low level modules and moves up to high level modules through the control flow of architecture structure. Low level modules are tested first, followed by high level modules. This approach is also known as inductive reasoning and result in increase in overall software development success rate. Advantage of bottom up integration testing: it is easy to create and develop test condition. Test results are easy to observe. Detailed knowledge of the structural design is not necessary. Low level utilities are tested well and are compatible with object oriented structure. As you can see in the below diagram, there are module A, B, C, D, E, F, G, H and I. So module H and I are in bottom. So in bottom up integration testing, they will start from the module H, I, then go for F, G, and then they will go for the B, C, D, E, and then at the end A. Likewise they will go. But in top down integration testing, they will first check for the A, then they will go for B, C, D, E, and then last they will go for the F, G, H and I. So this is go likewise. Here we can see the difference between unit testing and integration testing. In unit testing, there is a 3 module, that is module A, B and C. So those are individually be tested. But in integration testing, there is also 3 module, but those 3 module are integrated with each other. So the integration part, the common part of module A and B, A and C and B, A and C, these 3 common parts will be tested as part of integration testing. System testing is a critical phase of software testing that assesses the overall functionality and performance of the fully integrated software solution. It determines whether the system meets a specified requirement and is ready to delivery to end user. This testing occurs after integration testing but before acceptance testing. In system testing, the integrated component from integration testing serve as input. The primary goal is to identify any irregularities between the integrated units. This type of testing is crucial for ensuring that the system functions are intended and meets the needs of its users. System testing offers several advantages. Testers do not need extensive programming knowledge to conduct this testing, making it accessible to the broader range of team members. It tests the entire product or software, allowing for the detection of an error or defect that may not have been identified during unit testing or integration testing. This testing environment mirrors the real world production or business environment, providing a more accurate assessment of the system's performance. It evaluates the entire functionality of the system using various test scripts covering both technical and business requirements. After system testing, the product is likely to have addressed most, if not all, possible bugs or errors, giving the development team confidence to proceed with acceptance testing. In summary, system testing plays a crucial role in ensuring the quality and functionality of a software system, helping to deliver a reliable and effective solution to end user. So this is the diagram where we can see the difference between functional testing, integration testing and system testing. So in functional testing there are independent module. At least we have one module to perform functional testing. So this is focused on the one module to check all the functionality and do a functional testing. In integration testing, to perform integration testing we should have at least dependent module. Dependent module means it is integrated to another module. So if it is integrated to another module, so we have to test the common functionality or integrated functionality. So that is called as integration testing. In system testing, this end to end flow. To perform system testing, all the modules should be ready. So this is end to end flow where we have to check from the all the module, from first module to last module, all the functionality we need to check. So this is called systems testing. Thanks for watching.